All right, so let's go ahead and look at this problem right here. We've got secant 4x equals -2. So again, this is a multiple angle. It's already solved for my trig function, so really all I need to do now is to go ahead and do my inverse. So I'm going to go ahead and set it up as 4x equals, and then I've got secant inverse of -2. Secant is the reciprocal of cosine, so this is no different than having cosine inverse. And what's the inverse of -2? -1/2. So that's what I'm looking for here, is whenever cosine is equal to -1/2 between 0 and 2 pi, because that's the restrictions that I was given for my domain. So now I'm going to have 4x is equal to, well, where does cosine equal -1/2? Well, it equals +1/2 at pi over 3. So it's going to equal -1/2 at 2 pi over 3. Why did I write pi? Okay, got 2 pi over 3. And then we're also going to have a couple more after that because it's a multiple angle, but let's figure out where our other spot is for it to also equal that. So on the other side of things, it's also going to equal -1/2 at 4 pi over 3, okay? So that's what I've got for my first two, and those would be my first two around the unit circle, my first rotation. Well, I'm going to have to do 4 rotations. So I'm going to keep on going around, and let's think about this. So if I'm adding 2 pi, right, but I needed to have a denominator of 3 in order to add, that's no different than having 6 pi over 3. So I'm just going to continuously add 6 to my numerator as I go until I get one that's going to get me over 2 pi, okay? So, well, I shouldn't say over 2 pi. It would be over 2 pi at the end when I get to it by dividing by 4. So it has to be over 8 pi because I'm doing around 4 rotations. So if you take 2 pi, multiply that by 4, okay, that's going to get me 8 pi, okay? So I need something that is going to go ahead and be equivalent to that or less than. So if I think about it this way, I'm going to write this with a denominator of 3. So that's going to be, if I do over 3, this has to be times 3. So I'm looking for all of my answers that I get down here by going around by 2 pi, by adding 6 pi over 3. I have to stop when I get to something that is 24 pi over 3 or larger. So I'm going to go ahead and do this. So if I take 2 pi over 3 and 4 pi over 3 and I add 6 pi over 3, that's going to get me 8 pi over 3 and 10 pi over 3. Okay, going to do the same thing. I'm going to add 6 pi over 3 again, and that's going to get me 14 pi over 3 and 16 pi over 3. I'm going to add 6 pi over 3 again, and that's going to get me 20 pi over 3 and 22 pi over 3. If I added 6 pi over 3 again, I'd be at 26 pi over 3, which is larger than 24 pi over 3. And that's why I know I need to stop. But as I told you earlier as well in the previous video, if this is multiplied by 4 here, that means I'm going to have 4 times the answers I would have had between 0 and 2 pi. So I'm going to go ahead, and now what I need to do is I need to get x by itself. Well, x here is multiplied by 4, so I'm going to divide by 4. And that's the equivalent over here to multiplying by 1 over 4. So that's going to cancel out my 4's there. And so now I'm going to have x equals, and I'm going to take each one of these, and I'm just going to multiply my denominator by 4. So that's going to get me 2 pi over 12, 4 pi over 12, 8 pi over 12, 10 pi over 12, 14 pi over 12, 16 pi over 12, 20 pi over 12, and 22 pi over 12. Now, obviously, I'm not completely done right now because I need to be able to reduce these, right? Because we don't write fractions that are not reduced as our final answer. So I'm going to go ahead and reduce each one of these, and so that's going to get me pi over 6, pi over 3. That's going to get me 4 pi. Oops, sorry, nope, just kidding. I can math. That's going to get me 2 pi over 3. I'm going to do this one here. I can do 5 pi over 6. And then 14 pi over 12 is going to get me 7 pi over 6. And then 16 pi over 12 is going to get me 4 pi over 3. 20 pi over 12 is going to get me 5. I can do this. 5 pi over 3. And then my last one here, 22 pi over 12, that's going to go ahead and reduce down to 11 pi over 6. Yeah. All right. So all of those answers, if I look at them, they are all between 0 and 2 pi, aren't they? So this is my final solution set. Yay. Okay, so now let's go ahead and look at this problem right here. This one, I don't have multiple angles. Instead, I just have, on this one, I just have a pi over 6 that's being added. So let's think about what that does to my graph itself. So here is a rough sketch of just a simple cosine graph. If I have a phase shift, so like I do in this case, where this pi over 6 is going to move my graph left, pi over 6, that graph right here is going to go left, however much that is, right? Now, if I think about that right here, and let's just pretend, I mean, this is not going to be true right this second because I don't have everything solved out, but let's say here and here were my two solutions between 0 and 2 pi that I was looking at in my original graph. But instead, it's been shifted to the left by pi over 6, okay? And so when that happens now what I've got to do is I've got to move that graph to the left, and you can see right here, this little spot, didn't follow it, but that little line right there would now be over here, and this one would still be here. So it's no longer a solution between 0 and 2 pi, and instead, I've got to bring in my graph again and do another period, and I'm going to find my next answer, which will be over here from my next one, okay? So keep in mind, if I have a left or right shift, my answers as I solve it might not be all in the domain restrictions that I have. I might have to add whatever my period is or subtract whatever my period is to get an answer that I need. So let's go ahead and solve this one. In this case, I have cosine. It's all by itself, just I've got the stuff in the parentheses there. So I can go ahead and pull out the x plus pi over 6 and set it equal to my cosine inverse, 1/2. Now I can go ahead and answer the question that I have here of at what angle is cosine equal to 1/2 between 0 and 2 pi. And cosine is equal to 1/2 at pi over 3. It's also going to be equal to 1/2 at 5 pi over 3, okay? So in this particular case, I don't have to worry about having multiple angles and having to do this a whole bunch of different times or anything like that. This is just what I've got right here. And so now what I'm going to go ahead and do, and you know, I'm going to rewrite this. I don't like how it looks. All right, so now right here, I went ahead and separated them out, so I have two separate equations. It's just more appealing to me to see it that way. And so now I can go ahead and subtract both sides by pi over 6 to get rid of the pi over 6 here that's attached to the x. and that's going to get x by itself. Now, keep in mind here, I'm subtracting fractions, so I have to have a common denominator. So I'm going to multiply by 2 right here, and same thing here. So really what I have is 2 pi over 6 minus pi over 6, and that's going to get me pi over 6. And then over here, I'm going to have 2 times 5 pi, so that's going to get me 10 pi over 6 minus pi over 6. So that's going to get me 9 pi over 6. Only problem here is I just need to reduce. So I'm going to go ahead and go, all right, so I've got x equals pi over 6, and then that 9 pi over 6 is going to go ahead and reduce down to 3 pi over 2. Now, both of those answers are less than 2 pi. They fall within the restrictions that I had of my domain of between 0 to 2 pi that I had up here. So those are both of my solutions. I don't have any more. I don't have any less. All right, let's look here at number 10. All right, on this one right here, again, I don't have a period change, but I do have a phase shift. I'm moving right pi over 2. So let's go ahead and solve. In order to do that, I have to get my trig function and its parentheses all by itself. So my very first step is to go ahead and add 2 to both sides. And now that's going to leave me with 3 times the tangent of x minus pi over 2. And on the right, I have 1 plus 2, so it equals 3. My next step to get my trig function by itself, I've just got to divide both sides by 3. So now I have tangent of x minus pi over 2 is equal to 1. Now my trig function is by itself. I can go ahead and do my inverse trig function. So I'm going to go ahead and pull out what I have inside the parentheses in x minus pi over 2. And now this is going to be equal to tangent inverse of 1. So the question here is, at what angle is tangent equal to 1? That's going to be at pi over 4. It's also going to be at 5 pi over 4. Okay? And now I'm just going to go ahead and solve those. So if I add pi over 2 to both sides, so let's add pi over 2 to both sides. If I added it here, let me get rid of it here, and add here. Get rid of there. So now I have x equals, and then I have pi over 4 plus pi over 2. Again, have to have a common denominator in order to do this, so I'm going to multiply this one by 2 on top and bottom, and same thing over here. So really I have pi over 4 plus 2 pi over 4, so that's going to get me 3 pi over 4. And then I'm going to do it again over here, and I have 5 pi over 4 plus 2 pi over 4, so that's going to get me 7 pi over 4. And that works. That's all I need to worry about here. Those are going to get me 2 solutions, and both of those are less than 0 to 2 pi.